Hello everyone, in this video we will be discussing conversions. All conversions which are involved in class 11 organic chemistry, that is including alkane, alkene, alkyne, benzene. Please see to it children you have completed learning part of the whole hydrocarbon, then only you can understand these conversions properly. Okay, now just let me move it this side so that maximum conversions, maximum compounds can be included in it, maximum conversions can be included. Now you can just see some compounds are marked in the boxes. That means this can be converted, and you can just check the arrows. Like this is methane. Arrow is going this side, means methane can be converted into, or methane can be prepared from. So like that it is. Okay, so now you can just see methyl chloride. From methyl chloride you can prepare methane. On the arrow I'll be writing the chemicals what are required. Okay, from methyl chloride to methane, it's basically reduction. So what you require is zinc and HCl. It's reduction of alkyl halide. You have studied in Alkane chapter, right? So same number of carbon atom you will be getting. From methyl chloride, if you carry out a reaction with sodium, 2 molecules of this methyl chloride with sodium in the presence of dry ether, then you can prepare ethane. That means from methyl chloride you can go either side. You can prepare methane if you are carrying out reduction. From methyl chloride you can prepare ethane if you are carrying out Wurtz reaction. This conversion which we are carrying out, methyl chloride to ethane, this is Wurtz reaction. That is WURTZ. It is Wurtz reaction. Okay. Now, this methane can be converted into methanol. That is, in the presence of some oxidizing agent. Methane, if you remember that children, in alkane you have done controlled oxidation. It is in the presence of copper. Okay, and the temperature 523, you will have to remember the temperatures 523 Kelvin and 100 atmosphere. So methane can be converted to this. Suppose you take ethane will be converted to ethyl alcohol then. Ethane can be converted to ethyl alcohol, the same temperature pressure. But since I have written here methanol, I am writing this equation. Methane can be converted to methanol. This is also oxidation. If you use a mild oxidizing agent, then methane can be converted into methanol. But if you are using comparatively a stronger oxidizing agent, that is molybdenum oxide, MO2O3, and then you are heating it. In the presence of this, you can prepare, methanol. Okay. Let me use dark color so that I hope this is visible. Then, okay. Now, ethane, from ethane you can prepare acid, ethanoic acid. From ethane, you can prepare ethanoic acid. You can prepare in the presence of again oxidizing agent. You can use manganese acetate, CH3COO taken twice Mn. In the presence of manganese acetate, you can oxidize it. From ethane, you can prepare this. This is also in controlled oxidation. You can prepare from ethanoic acid methane also. You can prepare methanoic acid, say methane. It's basically that first thing is you will have to treat this with ethanoic acid with sodium. When you treat this with sodium, what you will be getting is CH3COONA. First, this is Na to be treated with this. Then you will prepare sodium acetate. Sodium acetate then in the presence of soda lime. NaOH and CaO. 1 carbon less alkane is obtained. That means methane can be obtained. Okay, this is decarboxylation. Very important reaction in reducing the number of carbon atoms. Now, another thing. From ethanoic acid, you can prepare ethane also. Now, for this, again, ethanoic acid is to be treated with sodium. On treating with sodium, what you will get is sodium acetate. Then 2 moles of this when you carry out electrolysis. This is again a name reaction. It is Kolb's electrolysis. Okay, so this is giving you double the number of carbon atom. 1 carbon atom acid you have, alkyl part, otherwise 2 carbon only. So you are getting whatever the number of carbon atoms present here, that many carbon atoms alkane you will be obtaining. right? So this is, this part I have completed it. Actually, you can start from anywhere, but I just started from the left hand side. Now, ethane can be converted to ethyl bromide. Actually, this is to be done in limited quantity bromine if I take. If I carry out the reaction in the presence of bromine, in the presence of sunlight. More commonly, you have studied in your book as chloride. You can prepare chloride if you want. The basic thing is I wanted to show you alkyl halide. So I have taken here bromine. Okay, instead of chlorine, I used bromine. You can prepare ethyl bromide. Now, why did I use this? Because I will have to show the further conversions. Right? So, ethane can be converted to ethyl bromide. Then further you can check ethene can be converted to ethane. This is ethene. Ethene can be converted to ethane. This is very simple. You are just adding hydrogen in the presence of nickel, platinum or palladium. Any catalyst can be used. Even ethyne can be converted to ethane. Ethene can be converted. Ethyne can be converted. In this only thing is you will be using 2 hydrogen molecules in the presence of nickel, platinum or palladium. Right. So you prepared ethane. You prepared ethyl bromide from ethane. You can also prepare ethyl bromide from ethene. That is just by adding HBr. You add HBr to ethene, you can prepare this. From ethyl bromide also you can prepare ethene. How you can prepare is you will be using alcoholic KOH. That is a dehydrohalogenating agent. Okay, so all these will be very, very important in doing the conversions in organic chemistry. Ethene can be converted to formaldehyde. Yes, how can you convert this? This is ozonolysis. Adding ozone and then in the presence of zinc and water, hydrolysis. So basically you break both the bonds, add oxygen the either side, you can prepare formaldehyde. This is from ethene, you can prepare formaldehyde. Right, so this part we have done. Then you can also prepare ethene from ethyl alcohol. From ethyl alcohol you can prepare, that is basically removing water. So you can use concentrated sulfuric acid. Concentrated sulfuric acid will help in removing water. H from beta carbon, OH from alpha carbon, so you can prepare alkene. Next is you can prepare ethyl bromide se alcohol. So this is actually part of 12th aqueous KOH you will use. It's nucleophilic substitution reaction. Instead of Br, what you will get is OH. Right. So from ethene you can prepare ethyl alcohol also. You can prepare ethene from ethyl alcohol and then ethyl alcohol from ethene also. This is just by adding water molecule in the acid medium. So OH will add on, you will get ethyl alcohol. Right. Now you can prepare ethene from ethine. That is by adding H2. This is controlled hydrogenation. You can use palladium carbon. Okay, that is controlling hydrogenation. Lindlar's catalyst will be used to prepare alkene from alkyne. You can go reverse way also, but that is not just one step. What you do is you first add bromine. When you add bromine in the presence of CCl4, it will form vicinal dibromide. Br will add on. And then you will be using alcoholic KOH. Alcoholic KOH will help in removing one H and one Br. Further, you will be heating in the presence of Na and H2. So 3 reagents will be required to convert ethene to ethine. But you can convert it, and this is important, you can use it in some conversions. Okay, then further, let's move this side now. Ethine. Ethine you can convert into acetaldehyde. How can you carry out this reaction? You can first add water in the acid medium, so HOH will add on and then followed by tautomerism. Tautomerism will help in rearranging it to vinyl alcohol to acetaldehyde, which is most stable compound. You can prepare glyoxal. Glyoxal is CHO. How can you prepare this? Is by adding ozone followed by hydrolysis. That is ozonolysis. Add basically what is ozonolysis? The shortcut I told you, remove both the bonds, add O either side. You will prepare this. Clear? Now further, from this you can prepare, from ethine you can prepare higher alkynes also. You can prepare butane, you can prepare propyne, whatever. First thing is you will treat this, it's a terminal alkyne, you will treat this with one sodium atom. So one sodium will convert this one of the H into Na. So what you will have is NaC triple bond CH followed by reaction with methyl bromide. So when you treat this with methyl bromide, this part will go away as NaBr and you will get propyne. So higher alkynes can be prepared from lower alkynes by treating with sodium. Even this way you can go. In this case, you will treat ethyne with 2 sodium atoms. I'm not writing this reaction, it's similar type actually. Both sides Na will come and both sides CH3Br will be added on. You will get butane. So basically with sodium first and then treating with 2 molecules of methyl bromide. You will get butane. Okay. Next. This propyne you got. Propyne can be converted to propanone also. You can simply add water in the acid medium. So HOH will add as per Markovnikov's rule followed by tautomerism. So tautomerism will help in converting it into the stable compound, that is ketone. Clear? So I hope these are visible to you. So the part which you have written, I'll zoom it little bit so that you can take the screenshot and note down in your copy. You can just see this is the part which we have already done. Take the screenshot of it. These are the conversions which we have already done. Only that lower part benzene is left. Okay. So now let's do this. Ethyne can be converted to benzene. Ethyne, when you pass through red hot iron or copper tube, 3 molecules of ethyne will trimerize and will result in the formation of benzene. So benzene can be prepared by this. Next, you can convert normal hexane to benzene. Normal hexane can be converted into benzene. This reaction is aromatization. And how do you carry out aromatization? You can use actually any catalyst. The simplest one you can remember, vanadium pentoxide, and the temperature 773 Kelvin and 10 to 20 atmosphere. This is required. Normal hexane will get aromatized and it will result in the formation of benzene. From benzene you can go in any direction you feel like. Benzene can be converted into acetophenone. This is acetophenone, C6H5COCH3. It's basically Friedel-Crafts reaction. It's Friedel-Crafts acylation. You will treat this benzene with acetyl chloride in the presence of anhydrous aluminium chloride. It will result in the formation of acetophenone. Okay. Benzene can be converted to toluene, that is methyl benzene. This is also Friedel-Crafts alkylation. So it is methyl chloride in the presence of anhydrous AlCl3. What you will get is toluene. Clear? Then toluene can be converted into para-nitrotoluene. At times you are asked directly also. Like at times it's given. From benzene they ask you to prepare para-nitrotoluene. So in that case first you will prepare toluene and then toluene se para-nitro. Then you will carry out its nitration. Nitration is done in the presence of concentrated HNO3 and H2SO4. Okay, this is a nitration mixture. Okay, because CH3 is a ortho-para directing group. First toluene has to be prepared, not nitro. If nitro is done prepared first, then the methyl will go at meta position. If the two things, that is CH3 and NO2, are required at meta position, then nitro has to be introduced first. That is, nitration has to be done first. Otherwise, first toluene and then this one. From benzene, you want to prepare meta-nitrotoluene. Yeah, that is what I was telling you. So in this case, what you will do? First, you will prepare nitrobenzene, concentrated HNO3 and H2SO4. You will first prepare nitrobenzene. Nitrobenzene you will prepare, and then from nitrobenzene you will carry out the reaction with alkyl halide in the presence of that anhydrous AlCl3. Anhydrous AlCl3. Then you will get a meta product. From benzene, you want to prepare meta-nitrochlorobenzene. Again, the same thing. You prepare nitrobenzene first. From here to here, you will go. That is, from benzene, you first prepare nitrobenzene. And then from nitrobenzene, you can prepare this. You can go this way. It's actually directly, there is no reaction. You have to first prepare nitrobenzene and then go this way. This can be done by carrying out reaction with chlorine in the presence of anhydrous aluminium chloride. That is a normal chlorination reaction. Because nitro group is meta-directing, first you will introduce nitro group and then chloro. Suppose the two groups which you want to prepare, the product which you want to prepare, that nitro and chloro should be at para position. In this case, you will first carry out chlorination. That means benzene, you will first react with, chlorine and anhydrous AlCl3. You will first prepare chlorobenzene, and then chlorobenzene you will carry out further nitration, concentrated HNO3, H2SO4. So with this, you will first get in benzene Cl, and then when you carry out nitration, that nitro group will go at para position with respect to chlorine. Got it? Please take the screenshot of these conversions also, what are included in it. Now, there are some conversions, which are also very, very important, like 1 bromopropane to 2 bromopropane. Suppose this is asked. You want to go this way. Let me mark this way only. You want to go this way. First is you will take alcoholic KOH. You will remove bromine and H. 1 bromopropane is that 3 carbons and 1 bromine at the end. When you use alcoholic KOH, you will get a double bond here. And then 2 bromo means you will be adding HBr to it. So Br will add on as per Markovnikov's rule. Suppose you want to go reverse. From 2 bromo, you want to prepare 1 bromo. The first step is same. You will be using alcoholic KOH. You will get a double bond, that is propene you will get. Now you want at one position bromine. That means you will add HBr now as per anti-Markovnikov's rule. That means in the presence of peroxide. In the presence of peroxide, that Br will go at one position. Okay. Then from bute to ene, you want to prepare acetaldehyde. From bute to ene, you want to prepare ethanoic acid. From this to this, butene, let me write the butene structure. You want to prepare this. It's simple ozonolysis. You add ozone in the presence of zinc and water. So this double bond will break. O and O is to be added. It is simple ozonolysis. Okay. The next one is from butene ethanoic acid. This is simple oxidation. If you see in your book also it's given potassium permanganate, potassium dichromate, acidified. Acidified you are using. This is a strong oxidizing agent. In its presence you will prepare acid. I hope these conversions are also clear. Okay. Now you can just check. This is the whole conversion chart. Please take the screenshot of it so that you can have all the conversions in one go. Okay, these are all the conversions which are required for class 11. Okay. Please practice these conversions properly. Okay. Thank you.